we're going to start talking about polynomials. And a polynomial is just a sum or difference of one or more monomial. Now, what does sum or difference mean? Add or subtract, so you see pluses and minuses. And a monomial, we've kind of talked about that before, haven't we? Y'all heard me say that before. A monomial is when we have a number or a variable, or they're all connected through multiplication, right? We talked about them a little bit when we started exponent rules early in the last unit. So a monomial is when you just have a number or variables or they're squished together through multiplication. There are no pluses and minuses in a monomial. It might be a negative sign, but it's not adding or subtracting anything. So when we start adding and subtracting those monomials, it becomes a polynomial. Poly means more than one, right? Okay, so a polynomial means more than one monomial that are added or subtracted together. So something we're going to talk about with polynomials and monomials is the degree of it. Now, to get a degree of a monomial, what you do is you add your exponents for the whole term. Okay? You add your variable exponents. So you really don't care about the number at all. You're just going to look at the variables. So this first example, 4a squared b. Well, this b is to what power? First, so you add 2 plus 1 and get what? So it has degree 3. So this monomial 4a squared b has a degree of 3. Okay, you just add your variables. So this next monomial is just a constant, right? Doesn't have any variables with us, what we call a constant. So if it doesn't have any variables, we don't have any variable exponents to add, do we? So its degree is 0. Okay. Its degree is 0. And what do you think the degree is of negative 15 next to the 5th line of the third? Degree 8. Very good. So if it's just a monomial, to get its degree, you add the exponents. That's it. All right, let me get a red. Okay. So when you have a polynomial, that's more than one monomial added or subtracted together, right? So if you've got more than one monomial with adding and subtracting going on, then each monomial has its own degree. 2x squared has a degree, 5x has a degree, and 4 has a degree, right? What's the degree of this one? 2. What's the degree of 5x? 1. What's the degree of 4? 0. So to take the degree of the polynomial, it's going to be the highest of what you got. So what's bigger, 2, 1, or 0? 2. So that whole polynomial has a degree of 2. So if they're added and subtracted together, the degree is the highest individual one you have. Okay? You don't connect this one with this one with this one. It's not degree 3. Okay? If they're separated by pluses and minuses, you do each one individually, and the highest is the degree of the polynomial. So what do you think the degree is of the second polynomial right here? 5. The highest one you have is a 5.
Hunter Wetherly, come to the office. Hunter Wetherly.
All right, does that make sense? So if it's just a whole polynomial, to get its degree, you see which individual one is the highest. Now, these I made it kind of nice for you because these are in what we call decreasing order or descending order. They went highest to lowest exponents. Sometimes they're all mixed up, all right? All right, so let's talk about some more terms. Y'all write down these terms. Just the 3 little important mathematical terms for this unit. Let's see if I can zoom it. That might be better. is a coefficient?
It's a number with a variable.
It's a number with a variable, right? It's numbers in front of a variable, okay? So that means a constant is a what? It means a number that don't have a variable, right? Okay, coefficients and constants. Coefficients are numbers with variables. Constants are numbers without variables. So a leading coefficient does what it says. It's the very first coefficient when you have your polynomial in decreasing order. And we're going to talk about decreasing order in just a minute. Okay? So binomial and trinomial. You have a bicycle, how many wheels does it have? 2. If you have a tricycle, how many wheels does it have? 3. So a binomial is a polynomial that has 2 terms. Trinomial is a polynomial that has exactly 3 terms. Got it? So those are just some special ones. After there's like 4-term polynomials, we really don't have a special name for those. Okay, we just call them polynomials after that. All right. All right. So let's talk about this decreasing order. Go ahead and show you all of it. Decreasing order. I might have to shrink back down. I might not have room. Well, it's not letting me. Something. That's too far. Get it right, Isabel. Okay. Decreasing order. Now, sometimes you see that as descending order. I don't think I spelled that right. I don't know if it's S or C. I can't spell. So if you see descending order, it means the same thing as decreasing order. That means you're going what? Lowest to highest or highest to lowest? If it's decreasing, it's highest to lowest. Just sometimes they tell you decreasing and sometimes they say descending, okay? Which means highest to lowest. You're going to start with the biggest and go to the smallest. So when you're writing a polynomial in decreasing order, you're going to start with your highest degrees. Okay, that means you're looking at the exponents, not the coefficients. Okay, so the coefficients are the numbers in front of the variables. The exponents are the ones that are after the variables up high and middle, right? Okay, so we're looking at exponents. So what's the highest exponent we see in this first polynomial? 4. The 4th power. Now, y'all, that's a negative in front of that coefficient. So you need to make sure you write -5. You always keep the sign that's in front of the coefficient. -5x to the 4th. Then what's the next highest exponent? X to the 3rd power. So that's a +2x cubed. So I write plus 2x cubed. So all these have to be connected with pluses and minuses. What's the next highest exponent? A square, so it's a -6x squared. So keep the sign. And then what? +15x. So we write plus 15x. And then what goes last? The constant. So constants always go last in decreasing order if you have a constant. Okay, so everybody okay with that first one? It's pretty simple when there's only one variable, right? So the second, what kind of polynomial is that? Yeah, it's got 3 terms, so it's a trinomial. Very good. So the first one, we don't have a name. We just call it a polynomial, okay? But this one is actually a trinomial because it has 3 terms. Now, what's the degree of this monomial? 3. 3. 1 plus 2 is 3. What's the degree here? 4. 4. What's the degree here? 1. Which one has the highest degree? Yeah, the middle one, right? Right? So that one goes first. -2a squared b squared. Then what? Plus 5ab squared, and then plus 7a. Now, sometimes they might tie. Like if I had a cubed be the first, they would have the same degree, right? So then it really doesn't matter. Okay, if they tie, you can kind of swap the order. Does that make sense? All right. Now let's get into adding. Woohoo, doing some math today. All right, so the main bulk of our lesson, we're going to do adding and subtracting polynomials. And we're going to get a little bit into multiplying polynomials. We'll do a whole lot more multiplying polynomials tomorrow. That's basically what we're going to focus on tomorrow is multiplying, but we'll do a little bit of it today, kind of as an intro. Bless your heart. All right, when we add polynomials, what you're going to do basically is just combine like terms in decreasing order. Okay, that's what happens when you add polynomials. You're going to combine like terms and you're going to go it in decreasing order. So you're going to start with the highest exponents and go down to constants. Okay, now I know that I'm adding polynomials because the polynomials are separated with parentheses. Do y'all see that? And there's a plus sign between the parentheses. So that's how you know if you're adding, because there's pluses and minuses all throughout the problem. So you look between the parentheses to see if it's adding or subtracting. Okay, so whatever is between the parentheses is what you're doing. What kind of polynomial is this one? And this one is also a trinomial, right? Okay. All right. Have y'all got number one copy? All right. I like adding polynomials because you can usually do it all in one step. So what are my highest exponents? The third power, right? So I have a 2x to the third over here and a 1x to the third over here. So I'm going to combine like terms. Now, when I combine like terms, do we change exponents? No, we keep them the same, right? And we just add or subtract the coefficients. So that's a positive 2, and my coefficient on here is a positive 1. So what's 2 plus 1? 3. So that's going to be 3x to the third. Again, you do not change your exponents when you combine like terms. And I like to underline to let me know that I've already used that term. That's why I underline. All right, so then what's the next highest exponent? The squares, right? I got negative 5x squared, and I got a plus 1x squared. What's negative 5x squared plus 1x squared? Yep, negative 4x squared. Good. Bless you. And now what's my next highest exponent? X to the first power, right? And I only have one of those terms, don't I? It doesn't have any like term buddies. So if it don't have any like term buddies, you just copy it like it says. And then what goes last? Yeah, the constant. So this right here is my answer. So you just combine like terms in decreasing order. So when you're adding polynomials, you can get it done in one step. You really don't have to show any work on those. Okay? Just combine your like terms, go highest to lowest exponents. All right, copy down number 2. X squared plus x minus 6 plus the polynomial x squared plus 4x plus 10. Just 2 little simple trinomials. And it's a plus sign between the 2 parentheses, and that lets us know that we are adding. So we combine like terms in decreasing order. So what's our highest exponent we see on number 2? A square. So I got 3x squared plus 1x squared is what? 4x squared. Good. Then I go to x's. I've got 1x plus 4x is what? Positive 5x. So I put plus 5x. And then my constants, I have negative 6 plus 10. What is negative 6 plus 10? Positive 4. So you put plus 4. And there's your answer. Okay. Not bad, is it, friends? Ain't bad at all.
It's just a little confusing, like I like adding and stuff.
Yeah, you just gotta not change your exponents, but combine like terms for your coefficients. All right. All right, copy down number 3. After this one is a U try. Two trinomials again. And we are adding because there is a plus sign between your parentheses. Now, I keep pointing that out because your practice is going to have them all mixed up. Okay? So you always look between the parentheses to see if you're supposed to be adding or subtracting. Because if you're subtracting, it's a little bit different. And I'll show you in a minute. What's our highest exponents on number 3? Third power. So I've got a negative 1x to the third power plus 1x to the third power. What do I get when I combine those together? Negative 1 plus 1 is what? And 0 times x to the third is just 0, right? So those basically cancel each other out. They make 0, they cancel out. So we're not going to have an x to the third in our solution, okay? Pretty cool. Mathematical elimination right there. So then we go down to squares. So I have a negative 2x squared plus 3x squared is what? Yeah, so you can write 1x squared. I'm just going to write x squared because it's the same thing, right? And if you put 1x squared, I'm not going to mark it wrong. I know that's correct, okay? Plus 3x don't have any like term buddies. And then minus 12 don't have any like term buddies. So that one simplified a lot, it seems like, don't it? Okay. So any questions about adding polynomials? Y'all good? Y'all try this one. All right, check them with a neighbor, please. All right, y'all check with me. X to the third is our highest exponent, is that correct? 5x, oh, I meant to use pen, sorry. 5x to the third plus 3x to the third is 8x to the third. And then you go to your squares, negative 2x squared plus 4x squared is positive 2x squared. Did y'all get that? And then you go to x's where you only have a plus 4x, so copy that down. And then you just have a minus 6 for a constant, so you copy that. So raise your hand if you got that for your final solution. Any questions? All right, so what's next? Subtracting. All right, subtracting actually has 2 steps. Okay, adding basically had 1 step, and that was just combine like terms in decreasing order. Okay, subtracting has 1 extra step before you do that. So I don't require you to show work on adding, but I am going to require you to show one more step of work on subtracting. That's it. All right, and the only extra step is, first of all, you're going to look between the parentheses and see that there's a minus sign, and that lets us know that we're subtracting. So if there's a minus sign between your parentheses, your first step is to distribute a -1 to the second parentheses. Now, what is multiplying everything by -1 do? Just changes your sign, right? So you don't even have to think about it very much. If it's positive, change it to negative, negative, change to positive. And then your final step will be combining like terms in decreasing order. Now, you're not going to change the first parentheses at all on step 1. Okay? So for step 1, you're going to copy the first parentheses exactly like it says and just drop the parentheses off. And then for your second parentheses, you're going to change all the signs. You're going to copy the first parentheses just like it says, and then on second parentheses, change all the signs. Just watch me. Watch me. Y'all got the example copied yet? All right. So I'm going to stick a 1 right there because I'm going to distribute a -1 to the second parentheses. So anytime you have a minus between parentheses, you're going to distribute a -1. Now the first parentheses, nothing is changing. So I'm just going to copy 4n squared plus 5. Exactly like it says, no changes. I just leave off the parentheses. Okay. Now in the second parentheses, I'm multiplying everything by -1, so I'm going to change all the signs. So what's -1 times -2n squared? Positive 2n squared. What's -1 times positive 2n? Negative 2n. And what's -1 times -4? Positive 4. So that was step 1. I changed all the signs of the second parentheses. So you copy the first just like it is. The second one, you change all the signs. Now you do just like you did for adding. You're going to go decreasing order and combine like terms. So what's our highest exponents? N squares. So I have 4n squared plus 2n squared is what? 6n squared. And then I have my n's, and I only have one n, which is -2n. So copy that down. Minus 2n, and then your constants. Positive 5 plus 4 is what? Positive 9. And that is my solution. No, so it's just one extra step between. Okay, so you just have to show 2 lines of work. That's it. So if it's a minus between the parentheses, you distribute -1 to the second parentheses and then combine like terms. Okay. Copy down number 5, please. Is this an adding or subtracting problem? Because subtracting, how do you know? It's a minus between the two parentheses. Very good. Very good.
I love how it can be one that's completed, and the next day's freezing cold beyond.
It's hot in here. I'm getting hot.
I think cold outside.
No, it feels good outside. It was beautiful yesterday and Saturday. All right. So what do we do to the first parentheses? Yeah. So we copy it down, just like it says. Don't change nothing, or don't change anything, I should say. What do we do to the second parentheses? Yeah, multiply by -1, which means we change all the signs. So that positive 3x squared becomes negative 3x squared. The negative x becomes a positive x, and the -8 becomes a +8. Everybody okay with that? Then we combine like terms in decreasing order. So we look for our highest exponent. What is our highest exponent? X squared. So what is 4x squared minus 3x squared? 1x squared, which I'm just going to say x squared. If you put 1x squared, same thing. And then I go to x's. So negative 3x plus 1x is what? And then last is constants. Positive 5 plus 8 is positive 13. So there's my answer. So subtracting is really not that bad either. It's just one extra step. All right. Still not terrible. Okay. What's happening here? Yeah, we got extra variables. Now those are B's, not sixes. I really don't like B's for variables, but I used them anyway, apparently. Five a squared b plus 2ab minus 4b minus 12a squared b minus 4ab plus a. Are we adding or subtracting these? Yep. Between there is the minus sign. So that means we're going to distribute a -1. I keep losing my pen. All right. So what do we do to the first parentheses? Copy exactly like it says. So 5a squared b plus 2ab minus 4b. And what do we do to the second parentheses? Yep. So it becomes what do we do first? What do we write down first? Minus 12a squared b. Oops. And then
Plus 4AB.
plus 4ab. Now you'll see if you don't change one of them, it's going to mess up your whole answer, right? So you got to make sure that you keep the first exactly like it is and change all the signs in the second one. Y'all be careful when you have more than one variable. Just for instance, is an a squared b the same thing as an ab squared?
No.
No, those are not like terms. Okay? So the a's and the b's have to have the exact same exponent on them for them to be like terms. Okay? So which one do you think is my highest degrees I have going on?
A squared B.
Right, degree threes, right? Right? Degree threes. And so a squared b, 5a squared b right there, and then 12a squared b right there, all degree threes, aren't they? Are they like terms? Yeah, because on both of them, the a is squared and the b is to the first power, right? So those actually are like terms. So what is 5a squared b minus 12a squared b? -7a squared b. Y'all with me? And that's all my degree threes I got going on. So if you have any other degree threes that are not like terms with those, you would take those on as well. All right. Do we have any degree twos? What has a degree 2? What variables? AB. Okay. So I got a positive 2AB here and a positive 4AB here. Those are like terms, aren't they? Yep. A to the first and B to the first are like terms. So what's 2 plus 4? So that is 6AB. And that's all my degree 2s. What's left? Degree 1s. How many degree 1s do I have?
2.
I have 2 of them, and they're not like terms, are they? So even though a B and an A are both degree 1, they are not like terms. They're different variables. So to be like terms, you have the exact same variables. So when they kind of tie like this for the same degree, it doesn't matter the order technically. The way you'll most of the time see it done on like a multiple choice test is alphabetical order by the variables. Okay? So yeah, most of the time they'll just put them in alphabetical order. Okay? Not always. I agree. Sometimes they do. Sometimes they do. And it really don't matter because these things technically tie. So I don't care which order you put these myself. All right? It's mathematically correct either way. All right? Just make sure you go right here. outside. Come straight back. All right. So, anyways, so there's that. Y'all try this one. Don't shut it. Y'all try that one. Y'all need to take some Mucinex or something. Germex. Do you like I do my kids? You blow your nose? Germex. All right, y'all check them with somebody when you finish. You never know. Okay. So, is this adding or subtracting? Subtracting. Question, what kind of polynomial is the first one? It's a binomial because there's two of them, right? And this one is because there's three terms. Good job. So we're subtracting. So what do we do with the first polynomial when we're subtracting? Copy it. So 4x squared minus 7x. What do we do with the second one? Distribute -1, which means we change the sign. So what goes next? Now what? And then what? Plus 9. Okay, then what do we do? What's the highest exponent? X squared. So I have 4x squared minus 5x squared is what? So you can write -1x squared, or you can just write -x squared, okay? As long as you have that minus sign out there. Then what?
The -7x and -4x.
Yep, your x's. What's -7x minus 4x? And then what goes last? Plus 9. Raise your hand if you got that for your final answer. Are there any questions?
Is there more after this?
Yes.
I thought that was it.
Y'all ain't that lucky.
Is this trigonometry? No, this is algebra.
Blended to junior high math. Okay. Number 7 here says to find the perimeter. What shape is this?
Triangle.
All right, kindergartners, what shape is this?
Triangle.
It's a triangle. Okay. Oh, jeez. Oh, jeez. I'm going to have to get my Jonah to come ask y'all about the shapes.
Why is it number 8? I thought I'm at number 7, not number 8.
Because that you try, I didn't number it. I don't know. I didn't number you tries for whatever. Yeah, y'all don't. Yeah, whatever we want to call it. Number whatever. Triangle problem. Okay, find the perimeter. Now, what does it mean back in junior high and before then? How do you find the perimeter of an object? Add all the sides. So these are all binomials, aren't they?
Yeah.
Yeah. So you're just going to add those 3 binomials. So you're going to say 2x plus 1 in any order plus, what the heck? Plus 5x minus 4 plus x plus 7. You're just going to add all those binomials, right? And when you add, remember, you just combine like terms, decreasing order. So I just got x's and constants, right? Just got x's and constants. So if I add my x's, I combine like terms. What is 2x plus 5x plus 1x? 7x plus 1x is 8x. And then I add my constants, 1 minus 4 plus 7. Negative 3 plus 7 is positive 4. So there's my perimeter. Was that hard? Was that hard? No. 2 plus 5 is 7 plus 1 is 8. Y'all ready? All right, so we're going to start multiplying. We're going to start multiplying. We're going to multiply all day tomorrow. Okay? So we're going to just do, this is our intro to multiplying. All right? Now we're going to multiply starting with monomials. And I forgot that part of that number 8's missing something. Hang on. What's my favorite number today? 3 looks good. 3 looks good. Let's say that's 3x in front. 3x. Oh, there's a 3x on the next one. Y'all change that. 8's never let me down. 8's my favorite. I'll tell you why later. If you want to know.
Yeah, we will do that.
No. I don't want it on the YouTubes. All right. A monomial times a polynomial. So this is our monomial. It's outside. And then our polynomial is in parentheses. Now, what does this look like? Guess what it is? It's distributive property. The only thing is we're going to have like a lot of variables in there. Okay? It is distributive property. So you're going to take your outside monomial and make sure you multiply it times all your terms on the inside of the polynomial. Okay? Now, the thing is we learned something last unit called exponent rules, right? And for multiplying, if we multiply 2 things that have the same base, what do we do to the exponents? We add them. Okay? So let's just do it. 8x times 4x. So you multiply the coefficients. What's 8 times 4?
32.
32. Get my red pen again. 32. And then my x's, I add them. So we're not combining like terms. We're actually multiplying, which means we are going to change our exponents. So what's x to the first times x to the first?
X squared.
X squared, yeah. The rule is when we multiply 2 things that have the same base, we add the exponents. So that was 8x times 4x. And then we do 8x times negative 2. What's 8x times negative 2? Negative 16, and that one don't have a variable, so you keep it negative 16x. It's terrible, isn't it?
I've never seen anything worse.
Oh my gosh. Just wait till tomorrow. I'll blow your mind. All right, copy number 9. Copy number 9. So a little bit longer polynomial. This one has 4 terms. And the monomial is negative 3x to the 3rd power. So yes, we're going to use distributive property and multiply negative 3x to the third power times all 4 terms. So we're going to multiply the coefficients and we're going to add the exponents as we go. Okay? Okay. So I'm going to start with negative 3x cubed times 2x cubed. What's negative 3 times 2? Negative 6. What's x to the third times x to the third? X to the 6. Very good. Okay. Now, isn't that an understood negative 1 right there? Okay. What is negative 3 times negative 1? Positive 3. Good. Negative times a negative is always positive. And then x to the third times x squared, we add them and get what? X to the fifth. So yeah, we can't forget those exponent rules we just learned. All right, then we go to this term. What's negative 3 times 4?
Negative 12.
Negative 12. Whoops. And then what's x to the third times x?
X to the 4th.
X to the 4th. Very good. Let's keep erasing what I'm writing. And then, boom, ta-da. What's negative 3 times negative 3? Positive 9. And then just keep it x to the third. So if you don't have variables on both of them, you just keep the one you got. And there you go. And this is in simplest form because all of these are different exponents and they go greatest to least. Okay. There you go. Not terrible, is it? All right. I'm like laughing at the soundtrack to my video today.
Yeah,
It's elephants. It's okay. I'm used to it. My boys have been snotty since Christmas Day. All right. 2x squared y. So we got another variable added in with our monomial this time. Y'all see that? Okay. So but this time we're multiplying a monomial times a, what kind of polynomial is this? It's a trinomial. It's got 3 different monomials. Good job. All right. So same thing. You're going to multiply the coefficients. You're going to add your x's and add your y's. That's it. You only can add like bases. Okay? So the first term, what is 2 times negative 4? Negative 8. And then we add our x's. What do we get when we add our x's? And our y's will be? Yep. X cubed, y cubed, or x to the third, y to the third. Everybody okay with the first term? Okay, then we go to the middle term. Coefficients first. What's 2 times negative 3? Negative 6. And then we got x's, so we add our x's and get x to the third. And this one don't have a y, so you just keep that one y. So x to the third y is the variable is that one. Everybody okay with that? And then the last one, 2 times 5 is 10. And what's my variables going to say? X squared stays, and then y to the 4th. Now this one's really not in decreasing order, so you could fix that if you want, but on multiplying, I don't care. Okay, now, I'll just be honest with you, your practice is only going to have add and subtracting, but we're going to need this for tomorrow. No. Y'all try one, and then we got to do an area. That's it. Y'all quit trying to rush me. I'm having fun. I enjoy this.
This is easy, but I really feel like this is the longest lesson we've ever had.
It's because it's Monday. This is not even close to the longest lesson we've ever had.
No, it's
I just feel like this is gonna get way harder to.
No, some long equations that we used to do.
I feel like
Seem
we
like it
maybe
takes
should
forever.
not mention because it may be.
Some of it is, some of it's not. And it's not difficult, it's just kind of longer. Does that make sense?
So what you're saying is no middle school.
You got a quiz on Wednesday, so if you want to do that. You want to miss tomorrow and take your quiz on Wednesday, that's fine with me.
I thought you said you can't go to school.
Now, if you're running fever tomorrow, please don't come to school.
Watch me end up like actually have something happen in my school where I don't think I just said it.
I will.
Just cause I said it.
Just because you said it. Y'all got it done? What's 2 times negative 1? Negative 2. What's x squared times x squared? Good. Then you go to the middle term. What's 2 times x? 2 times 5? 10. And what's x squared times x? And then 2 times negative 1. And you keep x squared. Raise your hand if you got that when you multiplied. Are there any questions? One last thing. Can y'all just watch me? Okay. Well, you can keep writing. I'm not saying you can't. Find the area of this. What is this lovely picture? Technically, it's a quadrilateral because there's nothing that tells you that it's a rectangle because it don't show right angles and it don't show opposite sides congruent. But we'll call it a rectangle just because it looks like one. All right. How do you find the area of a rectangle? How do you find the area?
Oh, multiply.
Multiply what? Yeah. Okay. Y'all are supposed to memorize those things from like last year and the year before and the year before that, right? Area of a rectangle is length times width. So what are we multiplying here? Oh, that's a funky equal sign. X times what? 3x minus 7. And we can distribute that, right? What's 3 times, or x times 3x? 3x squared. What's x times negative 7? Now, area, well, you have units, right? Those are centimeters, right? What kind of units are on an area? Centimeter squared. Good. There you go. So y'all can do that, could you? All right, that's the end of notes for today. Hope you enjoyed that lovely lesson.